Okay, so picking up right where we left off in this video, we're going to do a little bit more prep. I probably should have included this in the last video, but I'm trying to keep these videos down to a reasonable size. So I mentioned in the last video the usage of tags in order to track what's on the board. We're also going to use tags to tentatively flag an object for its color to be changed, specifically a token. So if you're playing the game, say there's a white token here, and you place a black token here, what we're going to do is we're going to tentatively flag this one to be changed until we know what's beyond it. So as we said, a probe is going to move out in each of the 8 directions. So this will get flagged to be tentatively changed because these are opposing colors, but then when the probe reaches the blank square, we're going to change that tentative status back to not being changed because for the rules of Othello, you would need to have another black marker here, black token here, for this to change. And there's many other scenarios as well. But that's the whole idea, is that we need some way of tentatively flagging something to be changed and then have the ability to reverse that. So what we're going to do, we're going to create a few new tags. So we're going to create on one of our prefabs. We're going to click on one of our prefabs, excuse me, and for tag, we're going to choose Add Tag. Now remember, this isn't adding the tag to the prefab, this is just creating a whole new tab, a whole new tag with a G. So we're going to call this one UL because it's the upper left. So this is a tag for the upper left probe, and we're going to save that. We're also going to create a tag for this, for the square, because we need to know if the empty square has been collided. So for that, we're going to use E for empty. Okay, so that should give us what we need for new tags. So let's go to our square. Let's go to Open Prefab. We'll go to Tag, and we'll select E for empty. Now we need to make a few additions to our probe. So the probe itself, if you select it in the asset area, choose Open Prefab. What we need to do, we added the circle collider, so that way the probe can collide, collisions can be detected with the tokens. However, to apply motion, specifically velocity, we need there to be what's known as a rigid body. So add component, physics 2D, and then rigid body 2D. And the line change we're going to make here is for gravity scale 0. We don't want any gravity. So now we have the ability to apply velocity to the probe. Now the other thing that we're going to do is, it's a little bit hard to see, I did this between videos, I was practicing last night. I shrunk the collider because I'll explain why in a minute, but to shrink the collider, you can just click on Edit Collider with the Circle Collider 2D, and then you just grab one of the 4 control points and push in. But we'll get to that in a minute. Okay, so we've added a rigid body, which allows for the application of velocity. We've created a few new tags, and we flagged the square. We've tagged it as empty. What we can do now is we're going to give motion to this probe. This particular one is going to move in an upper left direction. So if you click, say, here, the probe is going to go out exactly on a diagonal. So to do that, what we're going to do is we're going to create a new script. So right-click, Create C#, and we will call this probe con. We might wind up making a script for each probe, or we might use the same script and based on certain factors determine which probe it's attached to. 6 one way, 1/2 dozen the other. For now, we're going to make just one script. So we're going to go to our probe object, open, and then put our script onto it, and then we open this up. So in the start area, so start occurs once, and it's before the first frame is updated. So this is where we're going to apply the initial velocity. Now, since this is in the upper left corner and we want it to move in the upper left, what we're going to do is get component, rigid body, 2D. Remember, we got to do the 2D version or else this won't work. And then velocity. And we said that it's going to be new vector 2 because you're only changing x and y because we're not in a 3D environment. X is going to be -2 because it's moving to the left, so that's by default a negative direction. And it's moving up, so that's positive. And that will give us the trajectory that we want. Now, the absolute value doesn't matter as long as it matches. So you might find this moves too slow. You might increase it to 3.3 or 4.4. The main thing is we need that slope to stay the same. So we need that ratio, that 1-to-1 ratio to be the same for this to work. Now what we're going to do is we are going to, for the probe, as I mentioned in the other video, when you create a sprite renderer component, by default, the ordering layer is 0. Now, in the final version, the probe won't be seen because it should be, this is a mechanic that the player should not see, the end user should not see, because it's basically the game logic, and so that should work invisibly. But for the purposes of troubleshooting and demonstrating what we're doing, change that to 3 so it's on top of everything. Now, in the previous video, I believe that for the square prefab, I added the probe, the handle for the probe. I usually refer to it as a variable, but I've been told it's not actually a variable. I think the Unity's term is a method. Bottom line is it's a string that's getting a value attached to it. I'm not going to get into that argument right now. So I don't think I actually linked this. So what I did is in the script, so for a click con, I added this, but I don't think I actually dragged and dropped the probe here. So make sure you do that if you haven't done that already. So now what we've done is this script is attached to the square. So we've created a awareness of the probe. Okay. So now what we can do is we can instantiate that probe. We can have the probe be spawned when you click on a square, because that's when you're placing a token on the board. So what we're going to do is down here, we're going to do instantiate, and functionally it's very similar to the token. It is instantiating the probe object. So what is being instantiated, where it's being instantiated, and again, transform.position. If there isn't anything in front of here, and there isn't, transform.position returns the location, the position of the object the script is attached to. It's attached to the square. So what is being instantiated? This object. Where is it being instantiated? At the location of the square that you're clicking on. And then the rotation of the object that is being instantiated. Again, in this particular project, it really doesn't matter because we haven't rotated anything, but we'll use the probe's own rotation. So again, 3 arguments: what, where, and its rotation. We'll save that. And then, since we said we're taking this approach where everything happens or nothing happens, we will therefore do the same thing for when the token is black. So this is when it's placing a white token. This is when it's placing a black token. So if I haven't forgotten anything, when we place a token, you should now see the probe appear and travel on the screen. So let's see if that works. So we'll just click, and sure enough, there it is. And see how it's traveling exactly corner to corner? That's why I said that that ratio matters, that it has to match. It has to be that 1-to-1 ratio, or else it won't travel properly. So I mean, if you want to click all the way down here, just to keep me honest, you can see that indeed it does maintain that corner-to-corner travel. And what we're going to do is there's going to be 8 probes. So one goes up that direction, one goes straight up, one goes to the upper right. And that's what I was talking about. We'd either create 8 scripts or one script with the 8 different velocities. So we'll cross that bridge when we come to it. So we have created the new tags. We have tagged the square object. We have added a rigid body to the probe. The probe now has velocity. And did we flag the probe with the new tag? No, we didn't. So we got to make sure we do that. So the new probe, we'll give it the UL tag. And just to make sure I didn't miss anything, okay, that has B, that has W, that has E, and that now has UL. So basically, when a collision occurs, we're going to use the tags to determine what has collided with what. And so there's going to basically be 2 checks. The probe will be checking to see what it's colliding with to determine if it should continue. Because as we said, if the probe reaches an empty square, it stops and nothing gets changed in that direction. So it has to keep checking what it's colliding with. Likewise, the tokens need to know what has collided with it, so a determination could be made as to whether or not it's tentatively going to be changed, and then ultimately if it is changed. So now what we need to do is we now need to create a variable to track the status of the probe. So for game flow, since this is going to be a static variable, so public static string. So again, this indicates what type of data is going to be stored, and then what I'm typing now is the name of the variable. So this will be, again, we're keeping that naming convention. It's going to be UL, and it's going to be UL, and then we'll do change, or you could do UL status, and you want it to have a default value, so no. N for now. So this is going to have 3 statuses. It's going to have no, as in don't change the tokens that have been flagged tentatively to be changed, or yes, do change them, or R for reverse. So those are the 3 possibilities. Because again, so let's save this. And again, I don't want to go through all the possibilities right now, but you place a token here, this would immediately be flagged. Well, once the probe collides with it, this would be flagged to be changed, but then we get to the empty, and then you want to reverse because the rules have not been met, the conditions have not been met. But if this is what we have, and then we do this, the probe going out this way would flag this one to be tentatively to be changed, then this one, and then when you reach this one, the probe stops, that variable changes to yes, and these go to yes. So the tokens are each going to be looking for that variable to determine whether or not it should be reversed. And again, I'm trying to ease up to this because it really starts to become a mouthful because, again, what makes it challenging is it's really a logic puzzle, and that is you have all these various conditions that could occur and that you are flagging something to potentially be changed but not definitely be changed. So that's what makes it a little bit slippery, a little bit kind of nebulous, is the fact that you need this third condition of we might change it. So no, don't change it. Yes, do change it, or maybe get changed. Okay, so now that we have all that in place, and like I said, I probably should have done this in the last video, we are really close to actually getting into the logic now, because all that's really left now that we put all that into place is we just need to put in the if-then statements that will determine whether or not the changes occur. So it's going to basically be a statement that it's going to be a section that's going to check for a collision. And in that collision, it's going to be some if-then statements to decide what is being collided with. So I think that is the end of the prep, and that the next video will just do that, and that will just about finish it up. As I mentioned, after that video, we'll then do the bells and whistles. Someone already mentioned about making the blocks glow when you point at them. So when you do a mouse over, that's really easy. I can show you how to do that. So that will be in the final video. And like I said, we'll do a few other things such as timers and stuff. So we're really close now. The next video, we should be able to dive right into the checking for collisions and then the series of if-then statements that will determine whether or not the tokens get their color changed. So I hope this was helpful, and look forward to finishing this up in the next couple videos.